let us work on this example, on this problem here. So find the volume of the solid resulting from revolving the region bounded by the curves y is equal to 4 minus x squared and y equals 1 from x equals of 0 to x equals square root of 3 about the y-axis. So above the y-axis. First thing you need to do here is to actually graph the function. You need to graph this so that you'll get an idea of what you're working with. Alright, so let's try to sketch a graph here. So y-axis, okay, x-axis, y. Alright, let's start with this one. Y is equal to 4x squared. So y is equal to 4x squared. Well, sorry, y is equal to 4 minus x squared. That's a parabola. That's a parabola that opens downward. Now, what we need to identify is its vertex. Recall that the vertex of a parabola is given by negative b over 2a. Well, as long as your parabola, the equation of your parabola is written in standard form, x squared plus bx plus c. Okay, so we don't have an x here. And that means the value of b is 0 for this particular example. That means x equals 0. Alright, so, and when x equals 0, the value of y is equal to 4. Okay, let's see if we can squeeze that in here. 1, 2, 3, 4. Alright, so this would be our point here, one of the points. 1, 2, 3, 4. Okay, now let's try to spread this out a bit. 1, and then let's say 2. Let's put 3 here. So again, we're trying to graph this. We figured out that the vertex is 0, 4. What is the value? What happens when x equals 1? When x equals 1, we have 4 minus 1, 3. That's nice. We have this right here. What about when x equals 2? When x equals 2, we have 4 minus 2 squared. 4 minus 2 squared. That's 4 minus 4. That's 0. Okay. So that means we have this shape here. Now wait. We need to also do this. Y equals 1. Y equals 1. That's a horizontal line passing through y equals 1. So we have a horizontal line here. And we are bounded from x equals 0 to x equals 3. So we are finding the volume of the solid. Okay, we are bounded from x equals 0 to square root of 3. What does that mean? Where's the square root of 3? It's somewhere here. Okay. So if we graph, let me just graph this first. If I graph this all the way here, if I follow the shape of the parabola, okay, it should end up somewhere here. And if I graph y equals 1, I should have this. Right? Now, as you can see, they meet at this particular point. And hopefully that is the square root of 3. They meet at the square root of 3, so that we won't have a problem with this. Is that the case? Is that the case? If when x equals 3 is y is equal to 1. You can verify that. You can easily verify that. So when y, so okay, I'm looking at this function here. Y equals 4 minus x squared. Now if I let the x be equal to square root of 3 and plug that in this equation, we have y equals 4 minus square root of 3 squared. Okay, right, that's clear. 4 minus, that will be 4 minus 3, it's equal to 1. Alright, so that means we are looking at this region here, and we want to revolve that with respect to the y-axis. How is that going to look like if you do that? Okay, so we should have something like Let me just estimate this. Let me look at this. So 1, 2, 3, 4, 5, 6. So somewhere here. Okay, so we have this region. Should up here. Okay, I'm only looking at this right here. Revolving it with respect to the y-axis. So regions should look something like this. I hope you can see that. I hope you can imagine that. So what is the volume of that? It's only up to here. We have some sort of a dome here. We're trying to figure out the volume of this. Okay. So now what we have here is a function of x here. Now remember that in the formula our function value determines the radius of the representative disks. In this case, our radius actually is given by the x values. So that means we have to rewrite this. Instead of y equals 4 minus x squared, we have to express this in terms of x. So that should give us what? X squared should be equal to 4 minus y. 4 minus y, and I can write this as x equal to square root of 4 minus y. I will only take the positive values. I'll only consider this side. So which means now I'm able to find a function of y. So we can now proceed and find the volume. The volume of this region is given by pi times the integral from 0 to square root of 3 of f of y squared times dy. So pi times 0 to pi times the integral from 0 to root 3, square root of 3 of f of y. F of y is this, 4 square root of 4 minus y. Wait, we are squaring that. So that means we have this. This looks manageable. This is now the integral from 0 to root 3 of 4 minus y times dy. Let's proceed. That's pi times, okay, let's integrate this. What do you get? You get 4y minus y squared over 2. Now evaluate this from 0 to 0 to root 3. Now you should be able to verify that this, after evaluating this, you should get 9 pi over 2. So this is how you find the volume of a solid resulting from revolving a region with respect to the y-axis.